Alright folks, today we are going to put together what we did the last two times. Okay, we're still going to be working with SOHCAHTOA, but this time we will use it to solve for both angles and sides in the same problem. Okay, so what we're doing today is called solving the right triangle, and in order to solve a triangle, all of the pieces on your triangle have to be filled in. Okay, so that means all three side lengths and all three angle measures. Now, in order to do that, they have to give you some of it. Okay, so the first thing you're going to notice about 1 through 6 is they all have your right angle given. Okay, that's a must because in order to use SOHCAHTOA, we must have a right triangle. Right? But then, they'll also give you two other pieces. Okay, so on this first one, you'll notice they have two sides, but over here we've got an angle in the side. What I want you to do for solving these problems, we have three unknown pieces. There's an angle here, and a side. On the second problem, we have a side, and an angle missing. I want you to look at the given information and ask yourself, which do you have more of, sides or angles? So looking at number 1 here, we're given one right angle and two sides. We have more sides. That means we're going to start by solving for the third side. That will usually be the easiest thing to do. So when we have two sides, we're not using SOHCAHTOA to solve for the third side because we don't have an angle to work with. We're going to use Pythagorean theorem. 6 squared plus 10 squared equals x squared. So we've got 36 plus 100 equals x squared. 136 equals x squared, and we need to take the square root of that, which is about 11.7. So our sides are done. Now we need to solve for our angles. Okay? It doesn't matter, now that you've decided what to do first, it doesn't matter which one you do next. Okay, so I'm just going to put a y at the bottom right here, okay, but it would have been okay if we put it there as well. Now, in order to solve for an angle, if we have two of them, we can just subtract to find the third, but if we only have one, we're using SOHCAHTOA. Okay, we'll mark the angle with SOHCAHTOA always, and then mark the sides we're working with. This 6 here was given to us opposite, and this 10 was given adjacent. We don't want to use the side that we solved for. Always use the given two sides. O and A tells us TOA, or tangent. So tangent of the angle, ours is y here, equals opposite on top, 6, adjacent on the bottom, 10. And what we have to do is solve for y. Okay, in this case, y is an angle. It's on the inside, so that means we use the inverse tangent to solve for y. Remember, we're doing that on both sides. But on the left, they cancel. Okay, so over here, we'll cancel those out, and we just have this y equals the inverse tangent of 6 over 10. Which is about 31 with rounding there. Okay. Now, the nice thing here, we had to work hard for these first two, but we don't have to work hard for that third angle ever, because we know that the two acute angles add up to 90. Just like last time, we'll take 90 minus the angle to get that missing one. So 90 minus 31, 59 degrees. And we're done. The last thing we're going to do before moving on, okay, it's what I call the 3-second check. We're going to make sure that all of these numbers check out. Okay, it doesn't take very long. It's 3 seconds of your time, and it makes sure you get the right answer. Make sure, first of all, that your hypotenuse is the biggest number. Okay, so that's obvious. And then you want to make sure the same thing works with your other sides. We know that the hypotenuse is the biggest number because it's across from the right angle. The same thing goes with the smallest angle. The smallest angle should be across from the smallest side in the triangle. Okay, so check your hypotenuse and then check that small goes with small. If that works, you're good to go. Second one over here. Again, our first question is, what do we have more of? Okay, looking in our picture, we've got one side and two angles. So we want to solve for this piece first. Again, never work hard for solving for that third angle. You take 90 minus. Well, if we take 90 minus 40, right a little lower, we get 50 degrees, and that's our first answer. Then the other two things are sides. Just like with over here, our angle, it didn't matter where we put y. It doesn't matter which side we solve for first. Okay, so I'll put x on the bottom here, but it doesn't matter which one. Again, we'll mark our angle, and we have to use SOHCAHTOA for a side this time because we are missing two of the sides. You can only use Pythagorean theorem when you know two already. So here, we've got the opposite and the adjacent again, so TOA. This time though, tangent, we know our angle, it's a 40, then equals opposite 20 over adjacent x. So we have to solve for x, okay, multiplying by x on both sides, gets rid of that denominator, and then we're left with x times the tangent of 40 equals 20. X isn't quite by itself here. We have to get rid of the tangent 40 by dividing. So we've got 20 divided by tangent 40, which is about 23.8. Okay, same thing goes for the next one. We're going to put a y here and a hypotenuse. And now we're using O and H. Okay, once you've used x, we're going to ignore it, just like we did with the first day of SOHCAHTOA 10.2. Right? We could use Pythagorean theorem here, but if we do that, we have to use this 23.8, and there's always a chance that we messed up on that. Okay, so the better bet is using the SOHCAHTOA twice, and that'll be O and H this time. So, S is for sine of the angle, stays 40, just like over here with tangent, equals the opposite side was 20, the hypotenuse was y. And we're doing the same process. We got to get rid of that denominator, multiply by y on both sides, and then we've got y times the sine of 40 equals 20 left, and we divide by sine 40 to get rid of that. Alright, so 20 divided by sine 40 in our calculator, we've got 31.1. A quick check here, hypotenuse is the biggest number, and the small angle goes with the small side. 20 is the smallest side of this triangle, 40 is the smallest angle of this triangle. So they pair up, small with small and big with big. Alright, next up, again, first question. What do you have more of? So on number 3, we have more sides. That means we're solving for the other side first. We need an x because in order to solve, we use Pythagorean theorem. So x squared plus 12 squared equals 14 squared. We've got 144 equals 196. We'll subtract 144 over. 196 minus 144 is 52. And then we're taking the square root of that to get 7.2. Sides are done. For y, you just pick an angle. It doesn't matter which one, but mark it and label your sides based on that. Again, we don't want to use this 7.2, this decimal that we came up with, if we can avoid it. We can, because this 12 is adjacent and this 14 is hypotenuse, so we can use the ka in SOHCAHTOA. So that means cosine of y equals adjacent is 12, hypotenuse is 14. And again, that y is on the inside of the triangle, so we're using the inverse to get rid of this. So inverse cosine of 12 over 14. And that angle is 31 degrees. So then the other one, we just take 90 minus that, remember? If you think you might forget, jot it down. And we get 59 degrees. Over on number 4. We have more angles, so the first thing we're doing is solving for that third angle, 90 minus. Then we set up an x and a y. We have to solve for them one at a time. Okay, it doesn't matter where you put your first side. Again, I don't care which one you solve for first. Okay, so put an x here. 5 then would be the opposite of the angle we were given, and this x where I put it would be the adjacent. That makes O and A tangent. After tangent, we always write the angle. Sometimes it's a number, sometimes it's a variable. This time it's 30. And then we set it equal to O over A. So that's 5 over x for us. We're solving for x. We have to get rid of that denominator. And then we've got x times the tangent of 30 degrees is equal to 5. Now we just divide by tangent 30. So 5 divided by tangent 30. It's about 8.7. And last one here, we're going to put a y up top and label that the hypotenuse to do SOHCAHTOA once again. We're using opposite in hypotenuse. Remember, we don't want to use this 8.7 if we can avoid it. And that tells us SO for sine. Same angle for these, sine of 30, and then equals, opposite is 5, hypotenuse is y. Multiplying by y on each side, we get y times sine 30 equals 5. And then we'll go ahead and divide by sine 30 on each side to get that y by itself. Those cancel, so y equals 5 divided by sine 30. And that comes out nicely to 10. Again, we're going to check it really quickly, making sure the hypotenuse is the biggest side. And then small angle goes with small side. Smallest angle is 30. Across from that is the smallest side, 5 out of our 3 side lengths here. Okay? So when we're solving these equations, be sure to check yourself with that, and be sure that you're labeling all the pieces in the picture. I told you it didn't matter where we put our x and y, so I won't be looking in your work to find x and y. I'm looking in your triangle, because your letters don't have to match, but your numbers do. Okay, your number 10 has to be on the hypotenuse. Your 8.7 has to be on this bottom side. Okay, 60 has to be in that top corner. It doesn't matter if you called it the opposite and adjacent, because we can do these problems a little bit differently. Okay, just make sure you label in the picture, and if you're labeling with an angle, you should have degrees on those. Okay? What I want you to do now is pause the video and take care of number 5 and number 6 for me to see if you understand how to solve for all of these. Okay, look back at the examples above. You've got 2 of each type where you add more angles, more sides, so that you can try those 5 and 6. Alright, the triangle here, all three sides are filled out, all three angles, the quick check. Small angle with small side, big angle, the 90 with the hypotenuse. So that works out. I will tell you when you're looking at this, your X and your Y do not have to match up with mine, but you should see the same work. You should have a sine and a cosine somewhere, and then you should have the same numbers in the same place as mine. Okay, that's how you know it works out. Then over on the second one here, number 6, we've got 21 here, and then our inverse, I put y here to start out with, and that's 43.6 degrees. Up here, 46.4 degrees, just by subtracting. But you can choose y up here. Your work would look different. Okay, you would have to use cosine if you put your y up here. Okay, so just be aware you don't have to have the same work for angles. The sides, it will look the same, but over here, angles wouldn't necessarily have to. Okay, so as long as you have those same numbers as me, you should be just fine. We're going to finish up by talking about a couple word problems here. The first one is talking about the Great Pyramid of Khufu in Egypt. It's the largest of all pyramids and was the tallest structure in the world for the last, or up until the last 100 years. We want to know the angle of inclination. Okay? Remember these words, an angle of incline. It's always going to be a horizontal segment in our picture when we go to solve that. So it also gives us this hint. It says the angle that the lateral face, or the side here, makes with the base or the bottom here. So this face and this edge, it's really talking about this angle right here in the corner. Now it's important because using this SOHCAHTOA, we have to have a right triangle. So I'm going to go ahead and draw that right triangle out here so I have a little bit more space. You'll notice this 450 is going up and down. So that's the vertical piece of my triangle. But the horizontal piece is not labeled. We've got this 756, but that's the entire way across, and we only want half of that. Okay, so you'll take your 756, divide it by 2, and that means this little piece is 378 feet across. Now that we have two sides, we can solve for that angle. We'll always need two pieces to be able to do this SOHCAHTOA. Okay, it may have two sides, or we may have one side and one angle. But now, let's use our triangle and this angle to figure out what we use. 450 is the opposite of that angle, and the 378 is the adjacent. So TOA tells us tangent. Our angle here is x, and then it's equal to 450 over 378. Since our x is on the inside of this triangle, we're using the inverse tangent on both sides to get rid of that tangent here, to get x by itself. And then x is just this inverse tangent. Now, I didn't hit the inverse, and that's good. Let's talk about this. If you ever get a weird looking decimal number, a lot of times a decimal less than 1 here, that just means you didn't hit the inverse. When I hit my shift here, it didn't actually register. Okay, so when you're doing your homework, if you have something like that happen, just know that that's what went wrong. You can't have a really small number like that coming out for an angle. It's very unlikely. So then this number looks more reasonable for an angle, and that rounds to 50. So our answer here, the angle of inclination, is 50 degrees. Last problem here. Says John is 6 foot tall. He's looking up at a building at an angle of 20 degrees. If he is standing 100 feet away from the building, how tall is it? Okay, so first thing we're going to do is draw John here. And he's standing on the ground, not floating, And then we've got another item here, the building, that we have to put in. Now, John is 6 foot tall, so this vertical distance with John is 6 feet. And it says he's looking up to a building at an angle of 20 degrees. So from John's eyeballs here, we're looking at the top of the building, and that's going to form a 20-degree angle. Now, it's important that when we're normally looking, when we're walking around, look straight out. So make a horizontal line segment from the eyeballs, and that will create your 20 degrees. Then it says he's standing 100 feet away from the building. So from John to the building is 100. We could label that on the ground, but you'll notice we just formed a right triangle. So put that 100 right on the triangle itself. The reason we need to do that is because we need to find the height of the building. Well, the height is this entire length here. But you'll see a piece of this vertical distance is on our right triangle. That'll be our x. Then the rest of it, if John walks over here to the building, this piece is going to be your 6 feet as well. So our height will be just x plus 6. Let's go solve for x. Using our angle as a reference, our x is opposite, our 100 is adjacent. So again, we're using TOA or tangent here. So starting out with tangent, then our angle, which is 20 degrees, equals opposite x over adjacent 100. And we just have to multiply by 100 on each side to solve. Now in this case, see how x is by itself? That means we've got 100 tangent 20 for our answer. We just have to type it in. So that's x. So right below x here, I'll write this 36.4, but then we have to add 6, this John's height, to get the total distance. And 36.4 plus 6 gives us 42.6, and then our label on all this stuff is feet. So our building is 42.6 feet tall. Okay. You have a few questions on your homework where you have to draw a picture. Some of the questions, the picture is drawn for you. If you have any questions on those in particular, please come see me.